Hello everyone, how are you doing? I trust you are all doing great. James from JTS Smith Tutoring here. Today we are looking at algebraic properties of matrices. To be precise, matrix inverses. Let's get going. Find an expression for a square matrix A satisfying A squared is equal to an identity matrix and give 3 examples of such 3 by 3 matrices. Take note, the dimension can be anything. But here we just want examples which are 3 by 3 matrices. All right, so we are given the condition that A squared is equal to an identity matrix. And we know that a matrix that satisfies A squared is equal to I is called an involution or involutory matrix, meaning that it is its own inverse. So A squared is equal to I implies that A multiplied by A inverse is equal to A inverse multiplied by A is equal to I. So what we are going to do here is we are going to left multiply throughout by the inverse of A. All right. Oh my God, lovely stuff. So A is going to be equal to its own inverse. So this is the required expression, which implies that A is an involution or involutory matrix. Right, now let us look at examples now. Example number 1, we've got an identity matrix. We all know that an identity matrix, when it is squared, is going to give you an identity matrix. And we know that the inverse of an identity matrix is the identity matrix itself. Right, we have a special type of a diagonal matrix here, which is called a signature matrix. Number 3, remember, when we talk of an elementary matrix, which is a matrix that is obtained by performing a single row operation on an identity matrix, we know the 3 basic row operations. But here in this case, we are only looking at one row operation, which is just the swapping of the rows. So in that case, the elementary matrix is its own inverse. So remember, it is also called an exchange matrix or a permutation matrix. We'll talk more about permutation matrices later on. So you can actually swap 2 rows or 2 columns and all that stuff. When you rearrange it like that, it becomes what? A permutation matrix. All right. And then we also have what you call a reflection matrix, which is also a special type of a signature matrix. So I want you to take note of something right here. Not all elementary matrices and permutation matrices are involutory. All permutation matrices obtained by an even number of swaps, they are involutory. So meaning that if you obtain a permutation matrix by an odd number of swaps, it is not involutory. All right, we'll talk more about these matrices in our other videos. Some reflection matrices, they are signature matrices, but not all reflection matrices are signature matrices. All right, beautiful. Awesome stuff. This is what we had for you for today. Till we meet again, don't do what Mama and I wouldn't do. See you soon.